So objective 7, we want to use properties of inverse functions to find exact values of certain composite functions. So we want to recall that f inverse of f of x is equal to x for all x in the domain of f, and then that f of f inverse of x is equal to x for all x in the domain of f inverse. So in terms of sign, this means that f inverse of f of x is equal to sine inverse of sine of x is equal to x, where then x is in between negative pi over 2 and pi over 2, including both. Then sine of sine inverse of x is equal to x, where now x has to be in between negative 1 and 1, including both. In terms of cosine, we say that cosine inverse of cosine x is equal to x, where x is between 0 and pi. Then if we have cosine of cosine inverse of x, this is still equal to x, where now x is between negative 1 and 1, including. Then lastly, for tangent, if we take tangent inverse of tangent of x, this is equal to x, where x is between negative pi over 2 and pi over 2. Then if we have tangent of tangent inverse of x is equal to x, where now x is equal to negative infinity, or x is between negative infinity and infinity, not including. So we see how this kind of changes our problems. So now for example 4, we want to find the exact value of each composite. So for part A, we have sine of sine inverse of pi. So let's go up and look at our identity here. So we have sine of sine inverse of pi. This means that our domain of our value here would have to be in between negative 1 and positive 1. So we see we have the value of pi, where pi is about 3.14, which is much greater than 1. So this tells us that, and we're going to move this over a little bit. This tells us since pi is not between negative 1 and 1, or it's not in the interval. So let's say that instead, since pi is not in the interval, negative 1 to 1, this means that sine inverse of pi is not defined. And if sine inverse of pi is not defined, then sine of sine inverse of pi is undefined as well. So since we're only focusing on a single interval, if whatever your theta or x value is and it does not fit in that interval, it just means that it's undefined. And your answer is going to be undefined. Whatever you have on the inside of this parentheses, that's going to be undefined as well. So it's really important to look at the actual value of theta or x that you're looking at. So all right, let's go into part B. So for part B, we have cosine inverse of cosine of negative 2 pi over 3. So if we look at our identity here, if we have cosine inverse of cosine of x, we know this is just equal to x, but x has to be between 0 and pi. So if we look at our value, our x value in this case is negative 2 pi over 3, which is negative, so that means that it's less than 0. But we can actually do something about it. So we do see that negative 2 pi over 3 is not in the interval of 0 to pi, but we can use our even or odd property to get that cosine of negative 2 pi over 3 is equal to cosine of 2 pi over 3. They are equal since cosine is an even function. So technically, this means that we can take cosine inverse of cosine of 2 pi over 3 instead. And we might run out of room with this one, but we'll see. Cosine inverse of cosine of 2 pi over 3, which 2 pi over 3 is in our interval. And we're going to continue up here. We're going to move this one down a little bit. Move our current problem up. So we'll say, let's change that color there. So continue this problem. 2 pi over 3 is now going to be in the interval from 0 to 2 pi. So we can use the identity that we defined earlier. Cosine of inverse of, or cosine inverse of cosine of negative 2 pi over 3 is going to be equal to cosine inverse of cosine of positive 2 pi over 3, which the identity just tells us that our answer is 2 pi over 3. Ah, wrong thing. We wanted the highlighter. There we go. I'll move this back a little bit. All right, so that was our answer there. Then for part C, we have tangent of tangent inverse of 2.4. So if we have tangent of tangent inverse, this means that x can be between negative infinity and infinity. And our x value in this case is 2.4. And 2.4 is definitely between between negative infinity and infinity. So for our answer, say 2.4 is in the interval negative infinity to infinity. So we get our answer, tangent of tangent inverse of 2.4 is going to be equal to 2.4. And there we go. So we saw the kind of 3 different things that can go on for problems like these. We either see, like in part A, that whenever we have our value of x isn't containing the interval, so we just can't do the problem, it would be undefined. We also see something like part B, where we have this value, it should be undefined, but we can actually manipulate it so that we can define it. And then for part C, where it obviously fit in the interval, so the answer was just x. So, all right, our next objective, we want to find the inverse function of a trigonometric function. So, for example 5, we want to find the inverse function f inverse of f of x is equal to 3 sine of x plus 2, where x is between negative pi over 2 and pi over 2 included. Then we want to state the domain of f inverse and the range of f and f inverse. So, all right, we want to find our inverse function where our original function is 3x plus 2. Our interval is between, or the function we're dealing with is sine, and our domain is in between negative pi over 2 and pi over 2, which means that this function is going to be 1 to 1. So our function is a sine function. And it's between, it's in the interval negative pi over 2 and pi over 2. So we can say f of x is 1 to 1 and has an inverse. So this just to state that we can actually find the inverse of this function. It's not that we can't find it. So we can go ahead and now actually find the inverse. So we talked about how the implicit inverse, or the implicit expression of the inverse, is if we just switch x and y and solve for y. So in our implicit version, our implicit expression, we're just going to switch x and y and solve for y. So our original function given to us is f of x is equal to 3 sine of x plus 2. F of x is the same thing as saying y. So this is really just y is equal to 3 sine of x plus 2. But remember, we're going to switch x and y. So this function is going to become x is equal to 3 sine of y plus 2. And now we're going to solve for y. So if we solve for y, in this case, we can go ahead and subtract 2 from both sides. We had x minus 2 is equal to 3 sine of y. We'll divide each side by 3. So over here, we subtract 2. Divide each side by 3, so we get x minus 2 over 3 is equal to sine of y. So over here, we divide it by 3. So now we have this expression sine of y is equal to x minus 2 over 3. But remember, we were solving for y, so what we're going to do is we're going to take the sine inverse of both sides. And this will give us sine inverse x minus 2 over 3 is equal to sine inverse of sine of y, which using, oh sorry, too many. Using our identities up here, we know that this is just going to let us equal y, which is equal to y. So now we get that our explicit expression is y is equal to sine inverse of x minus 2 over 3. So this is our explicit expression. All right, so part of our answer is found. We found the inverse function for f of x, where f of x had the domain of being in between negative pi over 2 and pi over 2. So this is one of our answers. But now what we want to do is we want to find the domain of f inverse and the range of f and f inverse. So we want to use the ideas that we learned in Math 126. So if we go all the way up here, revealing quite far up, we see that the domain of f is equal to the range of f inverse, and then the range of f is equal to the domain of f inverse. So this means that since we had the domain of f, we stated that it was between negative pi over 2 and pi over 2. This means that this is the value of the range of f inverse. So scrolling all the way back down here, here we go. We can say we know that the domain of f is equal to the range of f inverse, and the domain of f inverse is equal to the range of f. So what we already have here is our domain of f. So since our domain of f was between negative pi over 2 and pi over 2, our range of f inverse is going to be that. So we can just state this over here. Our range of f inverse is going to be the interval from negative pi over 2 to pi over 2. And now the other things that we want to find are the range of f and the domain of f inverse. So we'll say range of f, we'll place that there, and then the domain of f inverse here. We already know that our domain of f was negative pi over 2 less than or equal to x, which was less than or equal to pi over 2. So now we want to find the domain of f inverse. So we know that these values are going to be equal, so we're just looking for one value in this case. And we're going to need to write some stuff off to the side here. Actually, we'll block it off right here. So we know these values are going to be equal. If we go back up to our function here, we see that when we take sine of sine inverse, we see that our range is now -1 to 1. So in our function here, this means that in our original domain from negative pi over 2 to pi over 2, this range would have been something along the lines of -1 to 1. But we see our function is not just sine, it's 3 sine of x plus 2. So we have to alter this original range that would have been for sine and alter it so that it fits in with our new function 3 sine of x plus 2. This also means that we can use our value of x minus 2 over 3. We can also state this. So you can think of it as two different ways. You can think of, I need the range to fit the original function 3 sine of x plus 2, or you can think of it as x minus 2 over 3 has to be in the range of -1 to 1. So what would that then give us? So we can say x minus 2 over 3 must be in -1 to 1 from our original. So we can state that -1 is less than or equal to x minus 2 over 3, which is less than or equal to 1. And now we just want to solve for x. So if we want to solve for x, we can multiply each side now by 3 to get rid of the denominator of 3. Blanked out on that word for a minute. So we do that, then we'll end up getting -3 is less than or equal to x minus 2, which is less than or equal to 3. So we multiplied by 3. Then we're still solving for x, so we can add 2 to both sides. So when we add 2 to both sides, -3 plus 2 is going to give us a -1, which is less than or equal to x, which is less than or equal to 3 plus 2, which is 5. So we added 2. So now we have that x is between -1 and 5, which would make our function have the right range. So this would be our new range of f inverse, which also gave us that domain as well. So since this is technically the range of our function of f, this is also the domain of f inverse. So we can write this out. So our range of f would be -1 to 5. And here is my cat. She's in the way. So our range was from -1 to 5. So this means that our domain of f inverse would then be -1 less than or equal to x, which is less than or equal to 5. And these would be our domains and ranges for our regular function and our inverse function. So there we have it. So that is how we would go about finding the inverse function of an original function and then finding their respective domains and ranges. So our last objective here, objective 9, we have that we want to solve equations involving inverse trigonometric functions. So equations that contain inverse trigonometric functions are called inverse trigonometric equations. So instead of just looking at different types of expressions, we're now actually doing equations that involve trigonometric functions, or inverse trigonometric functions. So for example 6, we want to solve the equation that is 4 sine of inverse of x is equal to 2 pi. So what we want to do here is we want to isolate the inverse trig function and then solve for x. So if we have 4 sine inverse of x is equal to 2 pi, one thing that we can do definitely to try and isolate it is that we can divide each side by 4. So we originally have 4 sine inverse of x is equal to 2 pi. We can divide each side by 4, and that gives us sine of inverse of x is equal to 2 pi over 4, which is pi over 2. So here we divided by 4. So now we have sine inverse of x is equal to pi over 2. So we want to solve for x, which means that we have to get rid of our sine inverse, which means that we now have to take sine of both sides. So now we have sine of sine inverse of x is equal to sine pi over 2. So we took sine of each side. Then we know by our identity that this gives us x is just equal to sine of pi over 2, which we should know or at least be familiar with. According to our unit circle, we know that pi over 2 would be that 1/4 of a revolution, which corresponds to the point 0, 1, where we know that sine corresponds to y. This means that x is then equal to the value of y at that point, which is 1. So we get that x is equal to 1. And if we want to write out, sometimes my math lab or other things will ask us to give the solution set. And if we want to give the solution set is always going to be the set of all types of solutions. But in this case, we only have one solution, but if we want to give it in the solution set, all we would do, we would say that the solution set is 1, and we write 1 in curly braces. So we have to write 1 in those curly braces. That signifies that it is a solution set, not like an ordered pair or an interval or anything along those lines. So there we go. That finishes up our last example and the end of section 7.1. So I'll see you all again in section 7.2.